Hi folks, thanks for showing up for your learning. In this video we're going to cover basic exponent rules, multiplying powers, dividing powers, and raising powers to powers. Alright, so let's take a look first at basic exponent rules. These ones ask us to apply all of our rules actually that we looked at yesterday. So here, 2 to the 5 to the 2, I'm just going to show you the answer. Here we have to multiply the powers. So 5 times 2 is 10. So this is the same thing as 2 to the 10. Push enter, it will tell me it's true, and then you definitely want to go in here if you're having confusion and see those two different methods. Method 1 is the way you will remember this if you forget your rules, is you just expand things by multiplication. So multiply 2 by 5 times itself 2 times, and we get 2 to the 5 times 2 to the 5 here, and then you expand that out, and you see that you're multiplying by 2 10 different times. Okay, ultimately 10 2's are multiplied, so that's 2 to the 10. Cool. And then method 2, this is the way you want to memorize, and you're comfortable with forgetting because you know you can always reteach yourself if you don't feel helpless. And so then you get to the correct answer in both directions. That's good. Let's look at another one. 6 to the 5 times 6 to the 6 will be add the exponents 6 to the 11. Hooray. And then you can expand it by writing it out, and then you can see ultimately 11 sixes are multiplied. And we can realize that that means we're adding exponents here. Okay, let's do another. 6 to the 3 to the 5, 6 to the 15. Okay, I've already shown one of those. I'm actually going to show expand. That one is 4 to the 20. Let's look at a new problem. New problem. New problem. New problem. New problem. Really? There's never a dividing one? There we go. Okay, that took a while. All right, so this is just going to be 4 to the 1. It's just going to be 4. 4 to the 1. Right, so 4 to the 3 divided by 4 to the 2. You expand it out and write and draw a picture, and then divide away those. Those ones all cancel, and then you're just left with the 4. Ultimately, 1 4 left. Final answer 4. That's 4 to the 1. There you go. So that's how you do those. Okay. And once you've reviewed those, we can look at multiplying powers. These are a little trickier because we have a variety of variables to crunch together. But here again, you just eat these elephants bite by bite. So write it out. Minus 5x cubed y squared multiplied by 6 x squared y to the 5. Wow. Well, what do we do here? Multiplication, if I remember that a times b times c is equal to c times b times a, like it doesn't matter the order I multiply things in. 2 times 3 times 4 is the same thing as 4 times 3 times 2 is the same thing as 3 times 2 times 4. It doesn't matter. So I can rearrange these in ways that I can multiply them. So I can do minus 5 times 6, right, as one multiplication, and then x to the 3 times x squared, and then y to the 2 times y to the 5. And then just do all those multiplications. Minus 5 times 6, that's just minus 30. X cubed times x squared is x to the 5, because I add the exponents here. I'm kind of adding the exponents when I multiply. These little dots mean multiply. This is not minus. Okay, that's my multiply sign. And then y squared times y to the 5 is y to the 7, because I add 2 and 5. And so then I input that proudly, minus 30 times x to the 5, y to the 7. Hooray. And don't forget to pat yourself on the back when you get these correct. And so those are multiplying powers. Dividing powers works in a similar way. You just divide the parts that you can see. And note that they only want positive exponents in Desmos. So here's how we can do that. There's a couple ways. Copy it out. 8xy to the 8 over 4x to the 6 y to the 7. Okay, and then divide the parts that divide each other. So those would be common bases or numbers. 8 divided by 4 happens to be 2, and that will be 2 on top. Okay, x divided by x to the 6 will be, well, I can subtract the exponents if I want. I could do x to the 1 minus 6, because I take this exponent, x to the 1, and I subtract this exponent here, minus 6. Okay, but that's not a minus. That was just 6 over there. And then y to the 8 minus 7 I can do. And that will give me 2 times x to the negative 5, y to the 1. So I'm just going to write y. But it only wants positive exponents. So now I can write it this way. 2y over x to the 5. What? What? Well, this is why. Okay, this is why this happens. All right, when you have a negative exponent like x to the negative 3, that's the same thing as saying 1 over x to the 3. That's what the negative does, is it takes this base and kicks it to the other side of the fraction. If you ever ended up with something like this, 3 over x to the negative 5, that would be equal to 3x to the 5. This negative now kicks this downstairs element upstairs. So it's a little bit like Downton Abbey, where characters are always, they're going from upstairs to downstairs and downstairs to upstairs, and there's these things going up and down. And the negative exponent just means change your floor. Change your floor once. And you can only be upstairs or downstairs. That's what the negative exponent does. All right, so let's input our answer. 2y over x to the 5. 2y over x to the 5. Hey, let's do another one. This one is 9xy. Do I know that? Because 7 divided by 3 is 9. X to the 5 divided by x to the 4 is just x. It's x to the 5 minus 4, which is x to the 1. And then y to the 7 over y to the 6, that's just y. Okay, yeah. Let's take a look at a harder one. No, I want still a different one. Yeah, this one is good. This is perfect for my purposes. Okay, so 24 over 8. We just do that division. You just do it the way you've always done it. That's just 3, and it's 3 on the top. Okay. If you had 8 over 24, that would be 1 over 3. The 3 would be on the bottom. Okay. But we have 24 on the top, so the 3's on the top. Okay. So that's 3. X to the 6 over x to the 4, that's just x squared. And y to the 6 over y to the 8, we could write that as y to the minus 2, but why would you? Just see that there's more y's on the bottom. You're left with 2 of them down there. That's how I do them. Okay, 3x squared over y squared. There, that's how you do them. All right, now let's go to raising powers to powers. All right, when we raise powers to powers, in these cases, we multiply the exponents. But we want to raise everything in the bracket to that power. So if I have minus 3x squared y raised to the power 2, that's equal to, you can write it out with multiplication in this case, not that bad, x squared y multiplied by minus 3x squared y. And then rearrange so that you have minus 3 times minus 3, because this is minus 3 squared, x squared squared, and y squared. Okay, there's y times y gives you y squared. Minus 3 times minus 3 is minus 3 squared. Minus 3 squared is 9. X squared squared is x to the 4, because we multiply the exponents there. I did 2 times 2, not 2 plus 2, even though that happens to give me the same answer in this case. And y squared is just y squared. So that's my answer. 9x to the 4, y squared. Notice minus 3 times minus 3 is positive 9. So you do have to practice your signs with these problems. It's almost like they're really good practice. All right, let's keep going. 6x to the 4, y to the 3, all squared. Well, 6 squared is 36. X to the 4 to the 2 is x to the 8. And y to the 3 to the 2 is y to the 6. So you multiply the exponents. So you can do these very quickly once you have some practice. This one. Didn't we just do this one? 9x to the 4, y to the 6. All right, that's how you do these. Okay, so practice. Get some practice. All right, and we'll see you in the next video. Thanks for showing up for your learning. Bye.